Hello बच्चों, welcome everyone. Welcome to Sri Chaitanya Academy YouTube channel. I Harish Sen welcome you back to yet another good session, transition course session. So today we are going to complete our vectors part, right? So what is this? This is the last video basically we will be having for our transition course. And in this transition course, okay, what have we done? Till now we have done many things, okay, right? So let's start from the base, from the start. Let's start what we have done till now. So first of all we did functions, okay, we talked about what functions are. Second we talked about quadratic trigonometry, right, we talked about trigonometry. Then we talked about straight lines, right, straight lines, okay. Then we talked about quadratic equations, right. Then we moved on to differentiation, integration, and lastly we are doing the vectors part, right. So in vectors also I have done, right, many things, correct. So today we are going to start with the vector subtraction part, okay. So without wasting any time, let's start with this, okay. So first of all, so before starting with vector subtraction, no, you should know what vector addition is, right. And yesterday in the last class, right, those of who are new here, okay, you do one thing, you go to this playlist section, okay, there you will see transition course for JEE and NEET, okay. There you can see all the videos, okay, for chemistry as well, for physics as well, okay. For JEE student there is math also, correct. So in that I have clearly in the last class, right, talked about vector addition. And what was, so to revise, what was vector addition? Let's suppose if I have one vector A, right, and I have another vector B, and let's say theta is the angle between them, correct. Then the resultant of these two vectors is, let's say, some vector R, and this vector R makes an angle phi with vector A. So what are the two formulas? This R resultant, right, this resultant R, right, is equal to, so first of all what I am trying to calculate is the magnitude of this resultant, only the value, right. And what is that equal to? That is equal to A square plus B square plus 2AB cos theta plus 2AB cos theta, okay. So this was the resultant which we had here. Then the next, what is tan phi? Tan phi, the value of tan phi was equal to, now B, right, so this is B, so we will have B sin theta, right, upon A plus B cos theta, A plus B cos theta, okay. So this is what we had in our vector addition part, right. So now we will talk about the vector subtraction, okay. So what is vector subtraction? Vector subtraction is, we are basically trying to, if I have two vectors, vector A and vector B, right, then vector subtraction will be equal to vector A minus vector B, okay. Or in other words, what can I say? What is this A minus B? I can say this is addition of vector A and minus B vector, right. Can I say this also? That vector A plus of minus B, clear. So let's write vector A first of all. So I'll take the same example, right. I have vector A here, okay, and I have vector B here, and theta is the angle between them, So what is vector minus B? Okay, basically vector A plus vector B. But what is vector A plus minus vector B? So this will be vector A, and see vector, this, can I say this will be minus B vector here, okay, this is my minus B vector. So once I have A vector and B vector, right, what is this angle? This angle will be 180 minus theta, correct. This angle will be 180 minus theta. So what can I say? I can say that this quantity, okay, this term, right, can be represented as this, that I have vector A, right, I have vector B, okay, or let's say minus B, right, and the angle between them is how much? 180 minus theta, So the resultant of these two vectors, will be somewhere here, right, and this resultant will be how much? This will be vector A, right, plus of minus B vector, correct. So my next aim is to calculate this value of R, right. So basically I am going to use the same formula, and what is the formula? So let's use the formula to calculate the answer here. And what do I get, right? So let's use the formula simple. So what is the formula? Formula is vector r, modulus of r is basically a square plus b square. Now I'll say b square because magnitude is same, no? The magnitude will not change. If this length is, let's say, 2 meters, then this length will also be 2 meters. Okay, plus 2ab, and what is the angle between the two vectors? The vector is 180 minus theta. Vector is 180 minus theta. So I can say it will be cos of 180 minus theta under root. So what do I get? I get a square plus b square, right? And this will be how much? Plus 2ab, right? And what is cos 180 minus theta is? Cos 180 minus theta is minus cos theta under root. So this is how much? A square plus b square minus 2ab under root, right? And what this I can write? I can write a minus b whole square, right? A minus b, sorry, I did make a mistake, sorry. Okay, so what is the final answer? The final answer I can write as this, that the resultant r of a minus b, or I can say vector a minus vector b, can be written as a square plus b square minus 2ab cos theta, minus 2ab cos theta under root. Okay, for addition, what was the formula? For addition we had a plus here, for addition we had a plus here, for subtraction we have a negative here. Okay, that is the only difference here. And what if a is equal to b? If a is equal to b, right, I will substitute a equal to b here. So what do I get? The resultant r will be equal to a square plus b square minus 2ab cos theta, that is the formula, right, minus 2ab cos theta under root. If I keep a equals to b, I will get a square plus a square minus 2a square cos theta under root, right, and this will be a square. Okay, so 2a square minus 2a square, so I am taking 2a square common, 1 minus cos theta under root whole square. Okay, and this will give me 2a square, and if I try to solve this, this will give me 2 sine square theta by 2, 2 sine square theta by 2 under root. Okay, and finally this will give me 2a sine theta by 2, 2a sine theta by 2. Okay, how do I get this from this? Okay, is your homework. Okay, you please, because I have done this in the last class, that how to get this from this. Okay, basically the value of 1 minus cos theta is how much? 2 sine squared theta by 2, 2 sine squared theta by 2. Okay, so how to get this value? How to get this value is your homework. Please try to find this. Next, okay, so let's try to solve this, that can the resultant of two vectors be 0? Okay, so first option is yes, when the two vectors are same in magnitude and direction, right? So let's suppose if I have two vectors, vector a and vector b, right, they are both are same in magnitude and same in direction. Can it be 0? No, right? Then it is directly saying no. Let's check. Yes, when the two vectors are same in magnitude but opposite in direction. Basically it's trying to say that one vector is like this and other vector is like this, right? Correct. So if this is a vector, this will be minus a vector, and the resultant of them will be a plus of minus a, and that will be equal to 0. So I can say third option is my correct answer. Correct. Next, it is given that if p plus q is equal to vector p minus vector q, so what can be true, right? So what can I solve? How can I solve this question? Let's write this vector here. So p plus q is equal to vector p minus vector q. Correct. So what will this give me? This will give me c p vector. If I bring this p vector, this will become minus p vector plus q vector, and this will become plus q vector is equal to 0. So this will give me p vector will cancel with p vector, and I'll get 2q is equal to 0, and that gives me q vector is equal to 0. Right. So what is the correct answer? I'll get q vector is equal to 0. Okay. Next, two forces acting in the opposite direction having a resultant of 10 newtons. Okay, so basically he's trying to say that two forces are acting in opposite direction having a resultant of 10. Okay, so let's suppose if I have force 1 and this is force 2, right? I have two forces acting in opposite direction. And what is the resultant? So let's say if the net resultant is this direction, so this will become how much? F1 vector minus F2 vector, and that is equal to 10 newtons. Okay, I am only talking about the magnitude. Now, if they act at the right angles to each other, the resultant is 50. Okay, now he is trying to say that if they act at 90 degrees to each other, right? So this is F1, this is F2, right? And what is the resultant R? What is the resultant R? The resultant R will be A square plus B square plus 2AB cos how much? Cos 90, right? And what is cos 90? Cos 90 is 0. So finally I will get F1 square plus F2 square, right? And this is 0, right? And how much is this? This is equal to 50. This is equal to 50 given to me. Then the magnitude of the forces. So what? How many equations I have? I have two equations, right? This is my first equation. Oh, where did it go? Okay, so let's write it again. So this is my first equation and this is my second equation. So let's try to solve them. So what do I have? Okay, so I have F1 square. So I can say F1 minus F2 is equal to 10, right? And second is F1 square plus F2 square is equal to how much? 50 under root. Correct? I am assuming that F1 is greater than F2. Why? Because I am saying that F1 minus F2 is 10. Okay, anything can happen, no? F1 can also be bigger than F2 or F2 can also be greater than F1. But since I am writing this, I am assuming that F1 is greater than F2. Okay, so now let's do one thing. What can I do? I can substitute the value of F1 from here. So what is the value of F1? So it will become 10 plus F2 whole square plus F2 square is equal to 50 under root. Correct? Yes or no? So let's square both the sides. So I will get A square plus B square plus this will become 2AB, correct, plus F2 square is equal to, this will become 50 into 50, 2500. Okay, 2500. Clear? So see, we can solve the question. Okay, you can solve the question, but just by hit and trial I can solve the answer. This is what? This is the quadratic equation. Okay, this is a quadratic equation. This will be something like this: 2F2 square plus 20F2 plus 20F2 minus is equal to, this will become 2400. Okay, this is 20. So this is a quadratic equations, and when you solve this, right, I will get F2, right? I will get F2 as equal to 40, right? I will get F2 as equal to 40. Okay, and when you substitute this F2 equals to 40 here, you will get F1 as, sorry, F2 as 30. I'll get, sorry, I'll get F2 as 30. Clear? I'll get F2 as 30, and when I take this F2 as 30 and I put it here, I'll get F2 as 40. Okay, so these are the this is the correct answer which we get. Okay, please try to solve this quadratic equation, you'll get your answer. Next, this question, okay, this is a homework question because I have added many questions in this. Okay, you please try to solve them. I will share this PDF in the Telegram channel. Those of you who have not joined the Telegram channel, go in the description box, there you will find the link for the Telegram channel, and through that you will be able to access this PDF. Okay, so there are many questions for you to solve. Right, now we'll move on to the next topic. Right, what is the next topic? The polygon law. So what is that? It states that if the number of vectors are represented by the sides of an open polygon taken in same order. Okay, so basically what do I have? I have vector A, vector B and vector C. Right, in a triangle law, what do we have? We have two vectors. Right, in triangle law, what did I talk? That if I have vector A and if I have another vector B, right, if I have two vectors A and B and theta is the angle between them, right, then the resultant R is here. Correct? Or in other words, I can say vector A into vector B, right? Vector A, vector B taken in same order, right? And the resultant is given by the third side of the triangle taken in the opposite order, right? If I am writing vector A, vector B like this, vector C is the final one, correct? But in this is the continuation of the triangle. How many vectors I have? 1, 2, and instead of two vectors, I have 3 vectors, right? And this is my fourth vector, right? I can have any amount of vectors. In a polygon law, what is a polygon? Figure with many sides, no? A closed figure with many sides. So how many? So see, this is the first vector, right? So how do you write? So let's understand by this, okay? So this is my vector A, this is my vector B, right? This is my vector C, and this is my vector D. right? So now let's talk about this. What is this? This is, can I say this is the tail, this is the head, this is the tail, this is the head, this is the tail, this is the head, this is the tail, and this is the head. What do? You draw the vectors such that the tail of the first, right, head of the first joins with the tail of the second. Okay, then you join the head with the tail, head with the tail, and head with the tail. So the final resultant will be the tail of the first and the head of the first. Okay, so let's understand here, right? Let's look at the diagram, right? What do I have? Tail here, right? And for vector A, this is the head. With the head of the vector A, what I have joined? The tail of vector B. So the tail of vector B, right? This is the tail of vector B. And this is the head of vector B, right? Then this head of vector B is joined with the tail of vector C. So this is the tail of vector C. And this head of vector C, this is the head of vector C. Then this head of vector C is joined with the tail of vector D. This is the tail of vector D. And this is the head of vector D. This is the head of vector D. Correct? And what is the resultant? The resultant is the tail with the head. The tail with the head. Clear? So this is what the resultant which we have. Correct? And what is R2? So this is how you can see. Now let's suppose if I just wanted to calculate R1. If I just want to calculate R1. Right? So what is the R1? R1 is, this is tail, this is head, this is tail, this is head, right? So tail of vector A, tail of vector A. This is head of vector A, head of vector A. And this head of vector A is connected with the tail of vector B, with tail of vector B, and this is head of it. So what is the final R1? R1 is basically tail of vector A with the head of vector B. Tail of vector A with the head of vector B, and this is basically my R1. Clear? So this is what polygon law is. Clear? Now let's do one question for this. Yes, it is given that A vector plus B vector plus C vector plus D vector is equal to 0. Okay. Now, which of the following statements are incorrect? Correct. So now let's understand, okay, that if the sum of all the vectors is equal to 0, okay. So basically what is happening, that let's suppose if I have vector A, vector B, vector C, and this is my vector B, okay. I will have something like this. Why something like this? Because the final resultant, okay, what is the final resultant? That the resultant is 0. And how do you calculate the resultant? The resultant is calculated by, look here, that the tail of vector A, should be connected with head of vector D, Same thing here, that the tail of A which is here is connected with the head of vector D, and that should be 0. The distance between them should be 0. So we are getting the distance 0 here. Correct? So this is basically a closed figure. This is a closed polygon. So A, B, C and D each must be a null vector. Okay. So if all of them are null vector, correct? If this is 0, this is 0, this is 0, this is 0. Yes, finally I will get 0. So this is a correct option. But what do we have to calculate? Incorrect option. Correct? Magnitude of A plus C equals to magnitude of B plus D. Okay. So let's try to solve this. How can I find this? So A vector plus B vector, should be equal to how much? Minus C vector minus D vector. Correct? And what can I talk about this? If I take mod, I will say magnitude of A plus C is equal to, now magnitude, right? So magnitude is same here. So this can be written as magnitude of minus C minus D. Okay? Because if two vectors are equal, let's suppose this is some vector A plus B, let's say is some vector, let's say C1 dash, right? C dash vector. And let's say this is some C double dash vector, no? Because this will also be some new vector. So if two vectors are equal, right? When are two vectors equal? When they are equal in magnitude as well as direction. Clear? So this is also correct option. The magnitude of A can never be written in the sum of the magnitude of B, C and D. So what he is trying to say, that the magnitude of A can never be greater than the sum of the magnitude of B, C and D. So basically magnitude of A, correct, can never be greater than the sum of, right, what is the sum? So basically magnitude of C plus magnitude of D, right, plus magnitude of B. Right, he is saying that this is not possible. Right, this is not possible. So how to check this? Okay, how to check this? We will see that, right? But let's look at the last option also. B plus C must lie in the plane of A and D if A and D are not collinear, and in the line of A and D if they are collinear. Okay, so let's understand first this, right, that the magnitude of A can never be greater than the sum of magnitude of B, C and D, correct? So now how to calculate this? Okay, so let's suppose if this is magnitude, right, what I am calculating, just 1 minute. Right, okay, so obviously he is trying to say that this is not possible, no, because see, if I calculate the individual vectors, okay, then B plus C, if B and C are two vectors, no, how will I calculate the resultant of this? The magnitude of this will be B square plus C square plus 2BC cos theta. What is theta? Theta is the angle between them, right? Theta is the angle between the two vectors which we are trying to calculate, yes or no? So here basically we are taking the individual magnets, okay, individual magnitudes, okay, and this will be, so let's suppose if I write this, okay, B plus C plus D, and if I take this A that side, so this will become how much? Minus A, right? And if I take the magnitude, right, this should be equal. So the magnitude of sum of the total is equal to A, okay, the sum of the total is equal to A and individual is not equal to A, clear? So this will be the correct option. Next, okay, so there are many questions here, okay, please try to solve them. Okay, now we'll move on to the next part, that is the vector multiplication. Okay, so vector multiplication, so what do you mean by multiplication, right? So whenever I multiply two numbers, right, whenever I multiply two numbers, so let's say if I have two numbers, right, A and B, okay, A and B are two numbers, right, so how can I multiply? Okay, I think for this question, okay, I have to check, okay, I am not sure about this question, clear? I will check about this, okay, what is the correct answer. Please don't assume this is the correct answer right now, because I am a bit confused, okay. I will get back to this question, okay, or in the comment section or in the Telegram group, I will talk about this question again. Next, so we are talking about vector multiplication, okay. So there are two, let's suppose, types of vectors multiplication. So let's suppose if in normal maths, right, if I want to multiply two numbers, right, how will I multiply two numbers? So if A and B are two numbers, right, either I will say A into B, okay, or I will say A into B, right, they both mean the same thing for you, A, B, A, B, right. Basically, let's say if I have 2 into 3, this will be also equal to 6, and 2 into 3 will also be equal to 6. This is only true for scalars, correct? Only true for scalars when we have scalar quantity. But now since we are studying for vectors, right, they have different meanings, So in one place what do we have? We have dot product, and in the other we have the cross product, right? So what is the dot product? What does the dot product say? That if I have vector A and this is the dot, no, right? So this is the dot. So basically if I have two vectors A and B, then the dot product is given by A dot B. And if I have cross product, so this is A and cross B, A cross B, so this is multiplied, right, by a cross sign equals to C vector. Now what are this? This is basically a scalar product. This is also known as a scalar product, and this is known as a vector product. Right? So now why this is known as a scalar product and why this is known as a vector product? Because see, in this if I multiply the vector A and vector B, right, I have two vectors, vector A and vector B, right, and if I multiply it by C, if I get C, this C is basically a number, okay, or this is, I can say this is C is a scalar, okay, this C is a scalar, okay. But now if you talk about A and this is B, right, if I multiply vector A with vector B, what I am getting? I am getting some vector C, okay. So this is a vector which I am getting as my output, okay. This is a vector, this is not a scalar, okay. So that is why this is a scalar product, this is a scalar product and this is a vector product, okay. So this is the main difference. Now what can I, so let's talk about dot product more in detail. So let's suppose if I have two vectors, vector A and vector B, and what is this? Theta. What is theta? Theta is the angle between the two vectors, correct? So now what is dot product? So dot product for two vectors is vector A dot vector B is mod of A into mod of B into cos theta. What is mod of A? Mod of A is magnitude of vector A, magnitude of vector A, and what is mod of B? Mod of B is magnitude of vector B, right? So here I have vector A, here I have vector B, and this is the magnitude of this. So now let's understand that if this A and this also becomes A, right? If let's suppose vector B is also equal to A, then what can I say? That I have two vectors, vector A, correct, and vector B, my vector B, which is also equal to vector A, right? So what is the angle between the two vectors? Basically I am pointing in the same direction, no? So the theta angle between them will be 0. The theta, which is the angle between them, will be 0 degrees. And when the angle between them is 0 degrees, what is cos 0? So this will become A dot A. A dot A is equal to mod A into cos 0, right? And what is cos 0? Cos 0 is equal to 1, and this will become mod A square, okay? So this is basically A dot A, right? So this is simple way to find A dot A, okay? Or basically if I want to find A dot B, what is A dot B? Mod A mod B cos theta. Clear? So now let's talk about special cases, right? So what are the special cases? That if I have two vectors A and B, right? Let's suppose this is the first case in which the vector A and vector B, they are having angle theta between them, okay? So if the angle theta between them, then what is the resultant? I can say that A dot B is basically equal to mod A mod B into cos 0, right? So this will become how much? A mod B, and this is what is cos 0? Cos 0 is 1. This is my final answer. Next, let's suppose if the angle between them is 180 degrees. So what I'll do? A dot B is equal to mod A mod B cos, what is the angle between them? 180 degree. Now what is cos 180 degree? Cos 180 degree is minus 1, okay? Minus 1. So this will become how much? Minus mod of A into mod of B. This is A dot B. Finally, okay? Next, finally we'll talk about A dot B here. So A dot B is equal to mod A mod B into cos. Now what is the angle here? So the angle between the two vectors A and B is equal to 90. So what is cos 90? Cos 90 is equal to 0, right? So mod A dot B is equal to 0. So this is a very important case. This is a very important case, right? And what can I write? That if two vectors, okay, if two vectors A and B are perpendicular to each other, then their dot product will be 0. Dot product will be 0, okay? And right, they ask in questions, right, that if they are two vectors, okay, and they are perpendicular to each other, right? So basically this is the condition that you will use, that the A dot B is equal to 0, okay? So what are some properties of dot product? A dot product is commutative, right? Dot product is commutative means, let's suppose if I have vector A and this is vector B, if I find the dot product of A dot B, right? So let's find. So what is dot product of A dot B? So A dot B will be equal to mod A mod B, right, cos theta, because if this is vector A and this is vector B and theta is the angle between them, then I can say mod A mod B cos theta. What is B dot A? B dot A will be equal to mod B mod A into cos theta, right? Because same, the angle between B and A is same, right? So if you look here, this and this is same only because, right, this is something, now this is a scalar product, because this A into B, I can write, let's say A is 2, so 2 into 3 into some angle, no, let's say this is some cos theta, right? Or I can say 3 into 2 into some cos theta, right? So it will not make any difference. Next, dot product is distributive, right? So basically when I have B plus C and it is with dot product with A, right? So I can apply this dot product individually, okay? So first you apply with this and then you apply with this, Okay, so multiply, just normal multiplication inside, right? So A dot B plus A dot C. Dot product is always scalar, which I have already told you, right? Dot product is always scalar. Dot product of unit vectors. Okay, now we'll move on to the next part. We'll talk about dot product of unit vectors. So first of all, right, first thing is that what are unit vectors? No, what are unit vectors? So unit vectors, let's suppose if A is a vector, for vector A, right, what is the unit vector? The unit vector is basically vector divided by the magnitude of that vector. Okay, so what is unit vector? Basically unit vector is a vector with magnitude 1 in the direction of vector A. Okay, so what is this? This is the unit vector. What is the vector? It is a vector with magnitude 1 in the direction of vector A. Clear? So now let's suppose if I want to understand this by an example. Okay, so let's suppose if I say that, okay, walk 30 meters east. Walk 30 meters east. Okay, so let's say if I say walk 30 meters east, right? Let's say this is my question, what I am trying to say. Then what is the unit vector? Unit vector will be a vector with magnitude 1. So what is the magnitude? Let's say magnitude will be 1 meter and in the same direction, right? So 1 meter east. 1 meter east will be the unit vector. Okay, you can also say 1 centimeter, right? Because that is also more smaller, but let's suppose we are assuming this, okay, that meter is the smallest quantity I can measure. Next, okay, so we are talking about dot product of unit vector. Okay, so what are the unit vectors which we have? Okay, so let's talk about the unit vectors in terms of, okay, so first of all, what are the three axes which we have? Okay, so the three axes which we have are x axis, y axis and z axis. Okay, these are the three axes which we have, correct? Now any vector A, right, any vector A can be written as, look here, I can say it as a1x, right, a1x. So let's say any vector will have three components, no? An x component, right, y component and a z component. Yes or no? Let's suppose if I am standing in this room, okay, and I point in that direction. Let's say if I am standing in this room and I point in some random direction, right? So how to reach at this point? Let's say, so basically I am trying to do what I am trying to do that, let's say this is my axis, okay, this is my axis, okay, and if I want to reach at some point in my room, right? So what, let's say, so what are the ways I can reach? That I will first walk in x axis, right? Then I will walk in y axis, correct? So let's suppose if this is the origin, okay, at this point if this is the origin, I will walk in the x axis and I will walk in the y axis. But let's say if some point is here, okay, at this point, then how will I reach? Okay, so let's understand. First I will walk in some x axis, correct? Then I will walk in some y axis and then I will walk in some z axis, correct? So basically I am using all the three dimensions, correct? So this is, so to reach at this point, this is some vector I am using, this is some vector I am using, and this is the third vector I am using. Clear? So same thing, right? So any vector has some x component, some y component and some z component, correct? So now how will I tell you that how much I have to walk in x, how much you have to walk in y, and how much you have to walk in z, right? So I will say that, let's say if I say that you walk 3 units, 3 in x, I will say 3 in x, right? Let's say if I say 2 in y, and let's say if I say let's walk 5 in z, right? So this is the way I can tell you that, okay, walk 3 units in x, 2 units in y and 5 units in z, right? But this is not like mathematically good, right? Because I'm not able to express it properly. Okay, so for x, okay, so let's suppose if I say that, okay, 3 in x, so 3 in x I can say, right? So basically in other words I can say 3, right, into I cap, 3 into I cap. What is I cap? I cap is basically trying to tell us that, okay, what is I? I is trying to tell you that the direction or the unit vector in x direction is I cap. Okay, what is I cap? I cap is telling you that, let's suppose, see, what is 3 I cap? Let's understand 3 I cap, okay, together. So what is 3? 3 is telling me to walk. How much units? 3 units. How much in which direction? X direction. I means I cap means x direction. Let's suppose if I write, second is 2 j cap. 2 j cap. So what is 2 j cap? 2 is telling me to walk how much? 2 units. And what is j cap? J cap is telling me to walk in which direction? Y direction. Plus 5, right, into I will say k cap. 5 k cap. So what is 5? 5 is telling me to walk in 5 units. Okay, 5 is telling me that you walk 5 units. In which direction? K direction. What is k direction? K direction is z cap. Okay, so I will write it here that I cap. Okay, so let's write it here. Okay. So basically I will write it here that I cap is basically, it tells me or directs me towards x direction. Okay, or basically I can say a vector of unit length along x. Okay, a vector of unit length along x, correct? So let's say if I say that minus I, what is minus I? If I say I have minus I, correct? So what is minus I trying to say? Minus I is basically, it is telling me or directing me towards, okay, towards the negative direction, negative x direction. Simple as that. Okay, what are the unit vectors? Unit vectors is basically, it tells us you about the direction. Okay, it tells you about the direction. Clear? So now dot product in terms of rectangular coordinates, right? So what is this basically? Let's suppose if I have some vector A, okay, so this is given here that some vector A is given to me, right? So I told you that any vector, right, can be written in terms of the components, right? So what is Ax? So Ax basically tells us that how much you have to walk in x direction, right? Because I cap is here. Ay basically tells about the y component, and Az basically tells you about the z component. So I have vector A, this is my vector B, and finally I have some vector A dot B. I have to find, this is what I have to find. This is what I have to find, right? So first of all, let's try to find the dot product. So what is dot product? So A dot B, vector A dot vector B, let's write it here. So what do I have? I have Ax I cap plus Ay j cap plus Az k cap, right? Az k cap dot, this will become how much? Bx I cap plus By j cap plus Bz k cap, right? So this is x, y and z. Now what I'm trying to do, what I'll do, I'll multiply it, right? I'll multiply it term by term. So what do I have? I have Ax into Bx. See, what do I have? Ax, right, into Bx into I dot I, right? Then I will multiply this first term with this second term, right? So what do I get? Plus, this will be Ax into By into I dot j into I dot j. And finally, if I multiply this Ax into this Bz, this is my third term, I will get I dot k. Correct? Now, what I am trying to do, we are multiplying each and every term. Okay, so let's keep on multiplying. Let's keep on multiplying. So if I keep on multiplying, right, now my second thing is I multiply this Ay with this Bx. So what do I get? I get Ay into Bx, Ay into Bx. This will give me j dot I. plus then I will have ay into by, right? This will be j into j dot j plus then what do I have? Ay into bz, right? Ay into bz into this will be j dot k, correct? And finally this az, this will be az, correct, into bx, az into bx, right? This will be giving me k dot I plus this will be az into by, this will be az into by, and this will give me how much? K into j, this will give me k into j plus, and finally I have az into bz, az into bz, and this will give me k into k dot k, okay, k dot k. So how many terms I have? I have 9 terms here, no, right? 1 2 3, right? 4 5 6 7 8 9, right? And see, this term got multiplied with these 3 terms, again this term got with 3 terms multiplied, and this also got multiplied with 3 terms, correct? So that is why I get 9 terms. Now let's understand, okay? So now what we are trying to do, that now I will try to find that what is this I dot I, what is this I dot j, what is this I dot k, correct? So let's first find what is I dot I, okay? So what is I dot I, right? So now let's understand what is I. I is a vector, I cap is a vector along x direction, right? And what is the magnitude? With magnitude is 1, right? So now if I have another vector I, right, in same direction, so what is the angle between them? So I can say the angle between them is theta, right? So what is the dot product? So I can say mod of I, right, vector A, vector B cos theta, right? Now what is magnitude of I vector? It is 1, because length of a unit vector is 1, into this also unit vector is 1, into theta. What is the angle between them? The angle between them is 0, so I will get cos 0, right? And what is cos 0? Cos 0 I will get is 1. So this I dot I will also be equal to 1. Similarly, if I do j dot j, let's say if I do j dot j, right? If I do j dot j, right, what is j? J is a unit vector along y direction, right? A unit vector means magnitude is 1 and direction is along y direction, right? So what do I get? See, I will get how much? Let's write mod A, mod B cos. Now if I have 2 vectors along the y direction, what is the angle between them? Angle between them will be 0, right? So again cos 0. So what do I get? This will be 1 into cos 0 is 1, so again I will get 1, right? And similarly if you find for k also, what you will get? You will get 1 only. So what can I say? That if I do the dot product of the same vectors, right? So I dot I is 1, j dot j is 1, and k dot k is 1. Can I say this? Yes. But what if I multiply I with j? Let's suppose if I multiply I with j, sorry, so basically I am finding dot product of I dot j. So what is I dot j? Mod I mod j into, now what is the angle between I and j? So I is along x direction, j is along y direction. What is the angle? Angle is 90. So I will say cos 90, right? This will be how much? Mod I is 1, this is 1, and cos 90 is 0. So this will be equal to 0, right? So basically what can I say? I can say, alright, basically I can write in simple terms that, right, I can say that I dot I is equal to j dot j is equal to k dot k is equal to 1. Okay, this is very important formula. Okay, this is very important formula. But if I write about some I dot j is equal to, or so if I say I dot k, or let's say if I say j dot k, right, the dot product is 0. Okay, so basically from this, if we say that, because why? Because I comma j, I, j and k all are perpendicular to each other. All are perpendicular to each other. And I told you that if, right, if the unit vectors are perpendicular to each other, if the 2 vectors a and b are perpendicular to each other, then the dot product will be 0, right? So because the unit vectors are what? Perpendicular, that is why their dot product is 0. So I, j and k all are perpendicular to each other, that is why the dot product will be 0. So basically this is 0, correct? This is, what is I dot j, I dot k, this will be 0. Then what is this j dot I? This will be also equal to 0. What is this j dot j? What is j dot j? This will be equal to 1, correct? Similarly, I dot I will also be equal to 1. What is j dot k? J dot k will be also equal to 0. Now, what is k dot I? K dot I is perpendicular, that is 0. K and j both are 0, and k dot k, this will be also this will be equal to 1, correct? So now finally what do I have? Finally, what are the terms? The terms which are left is ax bx, ay by, and az bz, right? So this is what we have finally, ax bx, ay by, and az bz, right? So this is what you have to remember, right? What do I have to remember? I will have to remember that the dot product of a and b, a dot b is just multiply these coefficients, this ax bx, ay by, az bz. Just multiply this with this, right? Multiply this with this and multiply this with this, you will get your dot product. Clear? Now, next, application of dot product, right? So what are the applications of dot product that we have, right? So work done by constant force is what? So work done by constant force is the scalar product of force and displacement, right? So if I want to find work, okay, so this is a work, later on you will see in work per energy, right? In your work per energy chapter, okay, in work per energy, okay, later on in physics, right? When I will talk about work done, okay, I will say that work done is the dot product of force and displacement, right? What is F? F is force and S is displacement, right? So this is where the use of dot product will be there, right? Because now you may say that, okay, why do I have to do all this, right? Because later on, right, I will tell you simply like this, that okay, force is equal to 2i cap plus 3j cap, okay, and I will say that displacement d is equal to, let's say, 3k cap, okay, and I will say find the work done, okay, let's say this is the question, correct? So that time, right, you should be able to do this, perform this, okay? So I don't want you to remember everything, okay? If you're not able to remember this, no problem, but the only thing, right, that you have to remember is what? This dot product, that a dot b is how much? A dot b is ax bx, ay by, and az bz. So basically, what is dot product, right? So now understand here that here if I want to find the work done, if I want to find the work done, what is the F dot D, right? These are the two vectors which I have. What is the force vector? 2i cap plus 3j cap. And what is the k component? K is 0. So I'll say 0k cap. Correct? 0k cap. Dot. Now what is displacement vector? Is 3k cap. Now, so what is x and y? X is 0, 0i cap. Y is also 0, but k is 3k cap, right? K is 3k cap. Just now multiply. So 2 into 0 will give me 0, plus 3 into 0 will also give me 0, and finally 0 into 3 will also give me 0. So I will say finally the total work done is 0. Correct? And I will be able to solve the question very easily, right? But if you are not, if you don't have the dot product, then it will be very difficult for you to solve the question in this manner. Okay, clear? So I hope you understand the application of dot product, and this is not the only way where we will use the formula. Okay, for power, what is this? For power, the formula is F dot V, force into velocity, dot product of force and velocity. Next we have vector projection. Okay, next we are talking about vector position. Okay, so okay, only two applications I am giving you are, but there are not two applications. Okay, there are many applications that will be used. Now let's start with the next part. So next we are talking about vector projection. Okay, next we are talking about what is vector projection. So projection of A and B, A on B. So I have vector A, I have vector B, and the angle between them is theta. Correct? Now what I want to do, I want to project A on B. What I want to do, I want to find the projection of A on B, or I can say, right, that I want to find that how effect of A. What does this mean? This means that effect of A vector along the direction of B vector. Right, this is what A dot B means, right? Basically I am trying to find the projection of vector A along this B, right? So basically what we'll do, we'll draw a perpendicular like this. Okay, we'll draw a perpendicular like this, correct? And I will find that, okay, what is this length equal to? Okay, so if this is in this triangle, if you see, right, what is this? This magnitude will be mod A, right? This, so now this, what is this length? Okay, so if I want to find this length, right, let's draw a small triangle, right? This is 90, right? Let's say this is some value x, right? And let's say this is some magnitude A, and this is theta, correct? So what is this? So this length x, right, will be equal to how much? Mod A into cos theta, mod A into cos theta, sorry, x. So basically I can say, see, what is cos theta? Cos theta is equal to base. For this triangle, what is this? X is the base, no? And what is hypotenuse? The longest side is mod A, right? So from this I can write this, correct? So basically what are we trying to do? Basically we are trying to find the projection of vector A on the vector B. Yes or no? So let's suppose that when I have vector A, okay, and if I want to find this here, correct? Yes or no? Then what, basically let's suppose if I want to find the direction of this, if I want to find the direction of this, how will I find the direction? So the direction is given by this unit vector along this direction, no? Okay, if I have a unit vector along this direction, right, correct? If I have a unit vector, I will basically be able to tell the direction. Okay, so a vector, to write any vector, okay, to write any vector, right, to write any vector, what do you need? You need magnitude plus some direction, right? To write any vector, we need magnitude plus direction. Now what is the magnitude we have? Right, magnitude we are able to find. This magnitude is this x length, because this is the length x which we want to find. Okay, but now what about the direction? The direction will be given by this unit vector B, right? So let's write this. So what is this basically? Okay, so this will be equal to magnitude. What is the magnitude? Magnitude is mod A into cos theta, mod A into cos theta, right? And the direction is given by the unit vector B. Okay, so this is basically giving me the magnitude and this is giving me the direction. But now what is, how can I write cos theta as, right? So cos theta, so basically if I do the dot product, A vector dot B vector, this will be mod A mod B into cos theta, right? This will give me mod A mod B cos theta. So what can I say? This will be equal to vector A dot vector B upon mod B. This will be equal to A mod A into cos theta, right? This will be equal to mod A cos theta. So let's substitute this value. This will be mod A cos theta will be equal to, right, this will be equal to B A vector, right, A vector dot B vector upon, right, this will be mod B into unit vector of B into unit vector of B, alright. So this is my final answer. Okay, but now what I expect you to do, right, I expect you to remember this thing. Okay, if you are able to remember this thing, right, you can write this formula very easily. You can write this formula very easily, because what is projection of A on B? Projection of A on B is effect of A along the direction of B. So whose direction I need? I need the direction of B, right, and the magnitude of A along B. So direction is basically, this is the direction which I get along B, and this is the effect or the magnitude of A along this. Clear? Now next move on to the next part. Basically now next what do I want to find? I want to find the projection of B on A, right? So basically now I want to find the projection of B on A. So basically I will say effect of B on A. So directions, so basically this will be effect of vector B on A, right? This is what I want to find, effect of vector B on A, correct? So now whose direction I need? I need the direction of A, right? I need the direction of A. So this is the direction I need, right? So this is the direction I need. And what is this direction? This direction is unit vector A, correct? Now What is the magnitude I have? So this is B. If this length is B, what is this length? This length X, right? This length X can be written as, I can say for this triangle X by B is equal to cos theta. So I can say X is equal to B cos theta here. Correct? Simple trigonometry. So just substitute it here. So this will be how much? This will be B cos theta, right? Basically the magnitude, okay? Magnitude we are talking about, right? Mod B, this will be mod B, right? So now how to substitute cos theta again? Again A dot B, vector A dot B is basically mod A mod B cos theta. So from this I can say mod B cos theta is equal to A dot B upon mod A dot B upon mod A. Just substitute the value here. So what do I have? I will have A vector dot B vector upon mod A vector into this B vector I can write as it is mod B, right, into unit vector of A. Okay, so this is how you can find it. But the most important thing is to understand that what projection means. Okay, what projection means. Let's try to solve this question. Okay, so it is given that the vector B is perpendicular to vector A. Okay, if these two vectors are given, okay, so I have vector A, and I have another vector B, right, and it is given that they both are perpendicular to each other, or I can say in other words the angle between them is 90 degrees, right. So if the angle theta is 90 degree between them, okay, if the angle between them is 90 degree, what does that mean, right? I told you right now that if two vectors are perpendicular to each other, then the dot product is mod A mod B, right, cos 90, right, and what is cos 90? Cos 90 is equal to 0. So that means that dot product will be equal to 0, correct. So let's find the dot product, simple as that. So dot product, that means that mod of A into mod of B should be equal to 0, correct. So now what is A? So what is A vector? A vector is 3i cap plus j cap plus 2k cap, right. This is vector A dot. Now what is vector B? Vector B is 5i cap plus 2j cap minus sk cap, okay. This is sk cap is equal to 0, okay. Let's write S in some other way. Okay, let's say this is some S we have to find. Sk cap is equal to 0 because dot product is 0. Now how to do the dot product, right? For dot product I told you that you multiply the I into I and I terms, then you multiply the j and the j terms, okay, the j and the j terms here, right, and finally you multiply the k and the k terms here. So what is this? 3 and this is 5. So this will give me 3 into 5 plus, right, what is this, right, for it is 1 here because this is 1 into j cap. So 1 is here written and this is 2, 1 into 2 plus, what is this? 2k. So 2 into, what is this here? Minus s is equal to 0. So what do I have? 5 3s are 15 plus 2 minus 2s is equal to 0, right. So this will give me how much? 17 minus 2s is equal to 0, correct, and this will give me s is equal to 17 by 2. S is equal to 17 by 2, okay. So this will give me 2 8s are 16 and 1, so 8.5. 8.5 is my final answer, okay. This is the S we are talking about, this is the S, okay. Clear? So finally answer is 8.5. Clear? So what is the condition that you have to remember? The condition that you have to remember is that the dot product of two perpendicular vectors is 0. Next, find the angle between the two vectors. Okay, now it is given that I have two vectors A and B and I have to find the angle between them. So let's say this is my vector A, this is my vector B, right, and I have to find the angle between them. So what is the formula I'll use? Again I'll use the same formula, that vector A dot vector B is equal to mod A mod B into cos theta, right. So now do I know A dot B? Do I know A dot B? No, I don't know how to calculate, but I know how to calculate A dot B, right. A dot B is not directly given to me, but I know I can calculate A dot B. So let's calculate A dot B very quickly. So 6 into 7, 6 into 7, 6 into 4 and minus 3 into 4. So let's calculate. 6 into 7 plus then 6 into 4, 6 into 4 plus this will be minus 3 into 4, minus 3 into 4, right? So now I am able to calculate A dot B is equal to, now what is mod of A? So modulus of A is under root, right? A square plus B square plus C square, right? So this will give me 6 square plus 6 square plus of minus 3 square into second, what is this? This will be 7 square plus 4 square, correct, plus 4 square into A dot B, right? So this is mod A, this is mod B into cos theta, correct? Now let's substitute the value. So 6 7s are 42 plus this will give me 24 and this will give me 12 is equal to, now what is this? 36 plus 36 plus 9 under root, and what is this? This will give me 49 plus 16 plus 16 under root into cos theta, So what do I get? I will get 42 plus 12 is equal to, now what is this? 36 plus 36 is how much? 72, and 72 plus 9 will give me 81. So this will be under root 81, and what is this? 49 plus 32, right? So what is 49 plus 32? 51, 61, right? So 49 plus 2 will give me 51 and plus 30, right? So that will give me 81. So this is also 81. So this will give me how much? 54, right? Into cos theta, I have to write here 54 is equal to, this will give me 9 into cos theta, right? So what do I have? 9 ones are 9 and 6 nines are 54. This will give me 3 2s are 6 and 3 3s are 9. So I will have 2 by 3 is equal to cos theta, right? So finally I have theta is cos inverse 2 by 3. So this is my correct answer. Okay, so this is how you have to use this dot product. Okay, and this is very important. Okay, in exams also the most of the questions are asked from dot product and cross product. Okay, so the three more important topics in your vectors are dot product, cross product and unit vectors. Okay, so now let's move on to the next part, that is the cross product. So what is dot product, right? So now see, we talked about dot product, that A dot B is mod A mod B cos theta, right? What is cross product? Cross product is vector product, because when I multiply two vectors, right, the third vector which I am getting, right, the resultant vector which I am getting is a vector itself. Okay, it is not a scalar like here. So see here that when I did A dot B, what is the value I am getting here? The value I am getting here is 54. Correct? When I do the dot product of two vectors, I am getting some value, no, I am getting some number here. But here I will not get a number, here I will get a vector itself. Okay, clear? Now, second, this C vector or the resultant vector is perpendicular to both A and B. Okay, what I will say, that the resultant is perpendicular to both vector A and B. Correct? So the resultant vector is perpendicular to both A and B. Okay, now next, the formula to calculate the magnitude is mod A mod B sin theta. Okay, there what is the formula? A dot B was mod A mod B into cos theta, right? But here when I do mod A mod B into sin theta, what I am able to calculate? I am only able to calculate the magnitude. Correct? Let's write it here, that we are with this formula, we can only calculate magnitude. Okay, we can only calculate magnitude, we will not be able to calculate the direction, right? So we will talk about how you will be able to calculate the direction, but this is very important. Correct? Now, so finally what is this? This is C cap. What is C cap? Basically this is telling me that the direction of this is in the direction of the vector C, but I don't know vector C, no? Correct? So this is just a normal formula. So let's understand. that how to calculate the direction of cross product. So first rule is right hand thumb rule. First rule is right hand thumb rule. And what does right hand thumb rule say? That if I am doing the cross product of A and B, right? If I am doing the cross product of A and B, you simply what you should do, let's understand this. So first is place your hand, okay, so first thing I'll do is place your hand along vector A, okay, or basically your fingers, okay, right hand fingers, okay, very important, right hand along vector A, okay. Then next step is, right, turn it towards vector B, okay. The thumb points in the direction of A cross B, okay. The thumb will point in the direction of A cross B, okay. So now what is this? Let's understand that. First is place your right hand along vector A. So this is my vector A, right? So I will place my vector along along vector A, right? Now where is vector B? Vector B is towards you, no? Vector B is towards you, okay. In this you should be able to understand that this is vector A is somewhere here, right? Vector C, this is vector A, vector B, and this is vector C, right? So first I will play my right hand, right? Sorry, I will take my right hand towards this, right? And then I will turn it towards vector B, right? Then I will turn it towards vector B. The direction of the thumb is pointing upwards, correct? The direction of the thumb is pointing upwards. That is the direction of my vector C, okay? That is my direction of vector C, okay? Let's do one more question, okay? So let's do some questions that will help you understand very easily, okay? Okay, now let's say that if I have some vector I cap cross j cap, right? I cap cross j cap, okay. I want to find the direction, right? So what is I cap? I cap is a vector along x direction, right? I cap is a vector along x direction. Now what do I have to do? I have to cross it along j cap. What is j cap? A vector along y direction, no? So now if I want to turn my fingers towards y, right, can I turn it like this? No, right, I cannot. What do I have to do? I will say I cap cross j cap, I cap cross j cap, and this j cap will be in the upper direction like this, correct? So I cross j and the thumb is pointing towards you, and what is this direction? This direction is basically k cap, okay. Now let's do one more exercise. If I say I cross minus k, what I am saying, minus I cross minus k. So where is minus I? Minus I will be along the negative x, correct? So negative x. And where is minus k? Minus k is negative z, right? So first of all minus I. So minus I is in this direction, and then k. What is k? So k, if k is towards you, minus k will be inside, right? So I cross minus k, I cross minus k, and this will be acting in the downward direction. This will be acting in the downward direction. And what is this? This is equal to minus j, right? This is equal to minus j, okay. So this is how, right, you basically try to find it, okay. I will give you one more question. Let's say if I want to find k cross k, let's say if I want to find k cross k, right, if I want to find k cross k, then what is k? K cap is towards you, and he is telling to turn it towards you only. Is this possible? See, understand, what is this? This is basically mod k into cos theta. What is cos theta? If I find the magnitude, this will give me mod k into cos, right? And what is the angle between them? The angle between them is 0, right? Sorry, this will be sine, not cos, because cos is used for dot product, right? So this will give me sine theta or sine 0. And what is sine 0? Sine 0 is equal to 0 only, right? This is sine 0, right? So this will give me 0, right? So we can say that k cross k is equal to 0. Next, the same thing can be understood by right hand screw rule. Okay, if you don't understand this right hand thumb rule, we can use right hand screw rule, right? What is this? That you try to take this a vector and b vector and in the direction of the screw, right? So let's suppose if understand that if I am twisting this in this direction, right, what will happen? It will go up, right? Similarly, what you can do that if let's say the vector a is pointing towards you, if the vector a is pointing towards you and the vector b is somewhere here, so what I'll do, vector a cross vector b, okay, and I close my hand, I curl my hand towards it, then the direction of the vector is given by the thumb's direction. Okay, so this is what my right hand screw rule is. Okay, basically both are the same thing. Okay, both are the same thing. Or you can basically do one more thing, right? Okay, either use this, that is the right hand thumb rule, or you use the right hand screw rule. Next, so what are the properties that we talk about? Okay, don't worry, we'll talk more about the right hand thumb rule as we move on. Okay, but let's move forward first. So cross product is an anti-commutative rule, right? It is anti-commutative. Why it is anti-commutative? Because a cross b is not same as b cross a. Sorry, a cross b is not same as b cross a, because okay, in dot product what do we see? That a dot b is equal to b dot a. Okay, a dot b is equal to b dot a, but a cross b is not equal to b cross a. Why it is not? Because directions are not same. Okay, direction are not same. That is the reason. That let's suppose if I have a along u, right? So a and let's say b is along this direction. So a cross b will be in the upper direction. But if I find b cross a will be in the downward direction. Correct? You understand? That let's suppose if I have two vectors, no? One vector a is pointing towards u and b vector is pointing towards this direction, let's say. Okay, and if I want to find a cross b, I'll say a cross b. What is the direction? In the upper direction, correct? But if I find b cross a, right? B cross a, what is the direction? I am getting in the downward direction, correct? So two vectors can never be equal if the directions are not same, right? So the same problem here arises, that a cross b is not equal to b cross a because directions are not same. Okay, so what is the thing we can do? We can say that the directions are opposite. So a cross b, right, is same as b cross a if I multiply with this minus sign. What happens with this minus sign? This minus sign corrects the direction. Okay, clear? Next, cross product is distributive. Okay, so basically we are saying next is cross product is distributive. So a cross b cross c, right? So basically what we are doing, right? We are second term. Okay, and we apply the cross product individually. So I will say a cross b plus a cross c. Okay, so distributive law is valid here. Now cross product of unit vector. Okay, so let's talk about cross product of unit vector. So first of all, I will say I dot I, right? So I cross I will be how much? So first of all, to find the magnitude only, okay? Okay, what is I cross I? What is I cross I? Right, so there are two. So to find first magnitude, okay, first thing we will find is magnitude. So to find the magnitude, what is the formula I'll use? Magnitude of I cross I is basically mod I sine theta, right? So I vector is along this direction, right? Another I vector will also be along this direction only. So the angle between them is 0, right? So this will be equal to mod of 1 into sine 0, right? And what is this? This will give me 0, correct? Similarly, if you find j cross j, what do you get? Magnitude of j cross j, right? It will be mod j into sine theta, right? So this will be equal to, what is magnitude of j? Magnitude of j is 1 into this will be sine 0. So this will give me 0. Okay, similarly k cross k, k cross k, right, will also be equal to 0. K cross k will also be equal to 0. Correct? So if, so now in the dot product it was opposite, no? In the dot product what do we see? That I dot I is 1, j dot j is 1 and k dot k is 1. But here it is opposite. Okay, so let's write it here that I cross I is equal to j cross j is equal to k cross k is equal to 0, is equal to 0. But now what about I cross j, right? Let's find that. Okay, so now let's suppose if I want to find I cross j, right? So first let's find the magnitude part. Okay, let's first find the magnitude part, right? So how do you find the magnitude? I cross j, magnitude is given by mod I mod j into cos theta, right? Now what is the angle between I and j? So let's suppose this is my I vector, right, and this is my j vector. So this is my I vector, this is my j vector, and the angle between them is how much? 90. Correct? So what I will say? I will say mod I, what is magnitude of them is 1 into cos 90, cos 90. And what is cos 90? Sorry, this is not cos, okay, cross product is sine. I'm sorry, this is sine 90, right? And this will be, what is sine 90? Sine 90 is equal to 1. Sine 90 will be equal to 1. Correct? So what do I get? 1. So I get I cross j, right? Magnitude of I cross j is equal to 1, right? So we get the magnitude. But now what about the direction? So for direction part, right? For direction, what do you do? Use the right hand thumb rule. And thumb rule. Okay, and what is the right hand thumb rule? That first you point towards vector A. Okay, first you put your hand towards the vector A, right, and then you turn towards vector B. Then when I turn towards vector B, A cross B, I cross J. So my thumb is pointing towards the outer direction, right, towards you, and that is k cap, right? So I will say I cross k, right? What do I get? Magnitude is 1 and direction is k cap. Okay, and direction. Next, okay, let's suppose if I want to find minus I cross minus k. Let's suppose if I want to find minus I cross minus k, right? So again, what do I need? I need the magnitude part, right? Again, I need the magnitude part. So what is magnitude? Magnitude will be equal to, see, I cross minus j modulus is mod of minus I mod of minus k. Sorry, I want to find k, right? This is k into cos. Now, what is the angle between minus I and minus k? So minus I and minus k, right? Minus I minus k. So minus I is in this direction, right? Minus k is in this direction. And what is the angle between them? If you check, the angle between them is 90 degrees. Okay, so the angle is 90 degrees. Correct? So since the angle is 90 degree, right, this will be equal to sine 90, and sine 90 is 1. So what is this? This will be 1 into 1 into 1. This is finally 1. Correct? So I have the magnitude as 1. But what about the direction? So 1 into, right? Where is minus I? Minus I is in this direction. Where is minus k? Minus k is in backward direction. No, I think I have made this wrong. Okay, so minus I is in this direction, right? And minus k is in this direction. So minus I cross minus k. Minus I cross minus k will give me downward direction, that is minus j. So what do I get? Into minus j. So this is basically minus j is my answer. Okay, so what can I say? That when I is not equal to j, okay, when I is not equal to j, the magnitude is equal to 1. Okay, so I cross j is equal to I cross k is equal to k cross j. Okay, they both all are equal to 1. Okay, clear? So I hope this is clear, and you can also find if some other term comes up. So cross product of rectangular components. Okay, so let's say if I have A and B, and if I want to find the cross product, right? So to find the dot product, what did we do? We just multiplied the coefficients ax bx plus ay by plus az bz, right? But if you want to find the cross product, okay, you make a determinant here, right? And how to find this determinant? Ijk, right? Ijk determines the directions, right? Just fit the values. This for I ax, j ay, k az, for I bx, for j by, and for k bz. Okay, and then we will try to solve this, right? So what is this cross product? So a cross b, right, will be equal to, first of all, you take this I, and you hide everything here, right? So you take this I and you hide j. Okay, I will write with minus j. So basically now next thing is, what I'll do, next thing is I'll hide this j part. I'll hide this j part and this row, right? So now what I'll do, I'll cross multiply this and I'll cross multiply this. Okay, why do I write minus j here? Okay, those that you will understand, right, when you in matrices you will understand that in math. Okay, but for now just understand that this is minus j. So what do I get? Ax bz, right, bz minus az into bx, and finally I will write the k part, right? Finally I'll write the k part. So when I take this k, right, so I will hide this and hide this. So I will cross multiply here. So what do I get? Finally I will get plus k, and this will be equal to how much? Ax by minus ay bx. Okay, ay bx. Clear? So this is how I will find A cross B in my questions. Okay, so next, if two vectors A and B are parallel, then please remember this condition. Okay, remember this condition, or in other words I can say that the cross product will be equal to 0. The cross product will be equal to 0. Clear? So now there are some applications of cross product, that how to find the area of a triangle. So let's say if A and B represent the sides of a triangle, then the area of the triangle is given by 1 by 2 A cross B. 1 by 2 A cross B. Okay, we just find the magnitude of cross product. Okay, next, area of a parallelogram is A cross B. There is no 1 by 2 here. Okay, and let's suppose D1 and D2 are the two diagonals of this, right, parallelogram. And the formula is 1 by 2 D1 cross D2. Okay, so there are many applications of cross product, right, in circular motion when we talk about that velocity. So let's suppose if this is a circular motion, okay, and let's say this is some radius r, okay, and my particle is moving with some velocity v, okay, and this is rotating with some angular velocity omega. Okay, don't worry, you don't know everything now, but you will understand that this will be applied in this circular motion chapter, okay, when you will be learning physics. Clear? So understand that these topics, okay, this is also some tangential acceleration also in circular motion. This you will be learning later on, right? So there are many things, okay, which you will be learning. These are some applications that you will be learning for the cross product in your later chapters. Clear? So I hope you liked the session, okay, and with this we finish the cross product part and with the vectors also. Okay, so I hope you enjoyed the session. Okay, and what I want you to do is, okay, if you are new and haven't covered all the parts in the transition course, right, go to the playlist section. There is a playlist known as transition course for JEE and NEET. Okay, you watch the videos because these videos will be very helpful for you later on when you start with physics, because without maths there is no physics. Okay, even if you understand the concept, you will not be able to get the answer, because you don't know how to calculate or how to do the calculation. Clear? So to neglect all those effects, right, this course is very important. Please watch the videos and solve questions. Okay, to get the PDF, okay, please join a Telegram group, right, that is in the description box of this channel. Okay, please go there and you will get the video, the link there. Okay, thank you everyone, have a nice day.